My Triumph Tiger 1050 recently reached a point where it needed some new tyres, and I decided to buy them online from blackcircles.com and fit them and balance them myself rather than going direct to the dealer. In so doing, in theory, it saved me £60, but it depends really on how successful I'm in fitting and balancing them myself. So I bought myself some components to make my own static balancer, and what that comprised was two sets of bearings and an 18mm diameter holder, which is designed to be fitted into a paddock stand. These, including the steel dowel, which is currently on the wheel, I'll put that one in a minute, was just over 15 quid. So if you can buy a static balancer for about anywhere between £90 and £150. Sealy make one in the UK. But I thought, well, it's going to get used so infrequently, for the sake of 15 quid, to buy the component parts and then just knock this up out of wood. So here we have the wheel mounted on the balancer, and the components that came for the £15, as I say, were the mounts, the 18mm shaft, including the two bearings for each side, the dowel, steel dowel, which runs through the middle of the wheel, and then the two mounting cones, one on this side and one on the far side of the wheel. So you get all the components that you need, all bar the wooden contraption, which quite frankly didn't take that long to make. Now, there are a lot of videos on YouTube showing how to do a static balance of a motorcycle wheel, but they're actually very superficial and they don't talk you through the ins and outs of how to do it accurately and the potential mistakes that you can make. And so the idea of making this video isn't just to show you crudely how to balance the wheel, because that's what all the other videos do. It's to show you how to do it as accurately as possible and to avoid making potential mistakes. Now, I'm going to split my description of the wheel balance into two separate halves, if you like. One is the limitation of the equipment and how to overcome inherent inaccuracies in the equipment itself, and the other one is a technique that you can use to balance the wheels as accurately as possible. So if we start with the limitations in the equipment, the first one is that obviously you want the wheel to rotate absolutely as freely as possible with no stiction, if you like, so no resistance to it turning. The immediately obvious one is any friction in these bearings. Now, when the kit arrived, these bearings are actually quite stiff, and the reason they're stiff is because they're packed with a kind of waxy grease. And I actually did try it initially without cleaning the bearings out, and you could put quite a lot of weight on the wheel before it would even show any signs of rotating, and clearly that's not satisfactory. I did watch one chap's YouTube video of balancing a wheel, and he commented on the same thing. And he suggested warming the bearings before you do the balance. Clearly that's unnecessary and it's not really going to solve your problem. The problem is they're packed with grease. So what I did is I took all four bearings off, put them in a jar of petrol for an hour, and just give them a good shake every 15 minutes or so, just to dissolve all the grease out of the bearing. Took them out, dried them, and then gave them a very light oiling with some light machine oil. And now, although I can't demonstrate it because the wheel's mounted, but if you get your finger on it and go like that, the bearing will spin freely. So all four bearings are nice and free. So that removes one source of possible error. Some of these errors that I'm going to discuss are actually very, very trivial, and so I'm kind of splitting hairs with some of them, but the more important ones I'll highlight. So obviously, having made this thing, make sure that when you mount the wheel, it's level that way, longitudinally and transversely. Make sure it's level both ways. Mount the bearings level. Now I put let's take this off a minute. If you put a spirit level across the bearings like so, there's actually a collar in here with a grub screw, so you can undo that, twist this until these are dead level and nip it up on both sides. So that's making sure those are level. Now let's just put this back on. Other sources of error, this bar needs to be absolutely straight. Now obviously if it's got a bend in it and it's kind of U-shaped, the wheel will want to settle with this bar at the bottom of the U, and then there'll be a significant amount of resistance to the wheel wanting to rotate. So check to make sure before you use it that the bar is absolutely straight. Now the other source of it having a bend in it and it will be minimal I suppose, it's just purely the mass of the wheel forcing the bar down. And you can reduce that by mounting these holders inboard a little bit so that the bearings fall just either side of the cone on both sides, and that way the actual bending force that you've got on this bar is kept to an absolute minimum. Another possible source of error is that the hole that had been machined in the middle of these mounting cones was actually about 1 millimetre more in diameter than the external diameter of the bar, and so they're actually a sloppy fit on the bar. So what I did is I wrapped 3 or 4 wraps of brown parcel wrapping tape around the bar so that these cones are an interference fit on the bar itself, so that again that takes up any slack. It might not sound a lot, but if you've got 0.5 millimetre either side of this, when you do the grub screw up, which you can see here, which holds it in place, that will push the cone to one side or the other. And if you've got 0.5 millimetre more radius on this side to what you have on this side, then that has got the potential to produce a bit of a moment and to corrupt your balance, your final balance. So again, easy to do, wrap some parcel tape around the rod so that you've got an interference fit, nip up the grub screw in the cone. Very, very minor point, this next one, but again, these cones are essentially symmetrical. The only mass which is eccentric, if you like, is the grub screw on each of them, and so I mounted the grub screw on each one on opposite sides. So the grub screw on this one is here, the grub screw on the far side is on this side is on the far side. So again, in theory that equals out, but I think it's a very, very trivial point, not least of all because the cone itself is so near the centre of rotation that any moment produced by out of balance masses on the cones is going to be negligible. So that's about it, I think. Make sure there's no friction, make sure there's no bends in this bar, mount your bearings in as close to the wheel as you possibly can to minimise any flex in these in the rod itself. Make sure the whole contraption is set level, and you're good to go. Right, I would stress that the balance we're about to perform on this wheel is a static balance and not a dynamic balance. The wheels as supplied by Triumph when the motorcycle was new had been balanced statically, and the reason I knew that is because they had exactly the same amount of lead on both the right and left hand side of the wheel rims in exactly the same place, and that applied to both the front and rear wheels. Had they been balanced dynamically, the amount of lead on right and left sides would have been almost certainly different and slightly staggered. So it is generally accepted that a dynamic balance on a motorcycle wheel is less important simply because the wheel is narrower. And so that obviously is also going to apply just so long as your wheel doesn't have any buckles in it, and it's absolutely true, which these are. The difference then between a static and a dynamic balance is with a static balance, it doesn't matter where you put the wheel, it will stay in that position. For example, if the wheel is 30 grams too heavy at this point, then to balance it you need 30 grams equally on the opposite side. With a dynamic balance, that 30 grams that it's out of balance, for example, could be on the far side. The centre of mass of that out of balance could be on the far side of the rim, which would mean that in order to balance it properly, you'd also need your 30 grams to balance it on the opposite side, but also on the far side of the rim. Now the reality is obviously a static balance doesn't take account of that, and you're not able to find out across the width of the wheel where where the centre of mass of that out of balance force effectively is. And so in theory, if you exaggerate this, let's say for example the wheel is out of balance by 30 grams on the far side of the rim at the top, and you statically balance it with 30 grams on the near side here at the bottom, then you have out of balance forces when the wheel is rotating wanting to wobble the wheel. So effectively one weight as the wheel's going round is making it want to do this, and the weight on the opposite side is exaggerating it and making it want to do the same. Again, the theory is with a motorcycle wheel, because they're of a finite width, they're relatively narrow compared to a car tyre, those out of balance forces are minimal, and again you can minimise any vibration, any wobbling vibration if you like, by making sure that you either put your masses in your balance weights dead in the middle, which of course in reality you're not going to do, or split the weights 50-50 and have them on either side. So 10 grams on the right, for example, and 10 grams on the left, which is what, as I said a moment ago, how this wheel was supplied to me. Most commercial wheel balances are designed for car wheels, but you can, in actual fact, put an adapter on them and balance motorcycle wheels dynamically. I don't know whether it's necessary. Strictly speaking, you would get a better result, subject of course to the accuracy of the technique that the operator uses. But I would stress again, I believe most motorcycle wheels are balanced statically, and that's what I intend to do with mine. Now, as far as the technique is concerned, most YouTube videos will tell you just to mount the wheel as it is now and release it, and the wheel will rotate until the heaviest point is at the bottom. And then all you do is mark the top and the bottom, rotate it through 90 degrees, and first of all, obviously, put an approximate amount of weight that you think you need at the top, rotate it into the 3 and 9 o'clock position and release it. If you've got too much weight, what was the lightest bit will go to the bottom. If you haven't got enough, what was the heaviest bit will still go to the bottom. So you adjust the amount of weight you've got attached until you bring it into the 3 and 9 o'clock position and release, and it doesn't go anywhere, and it doesn't matter where you put it, it doesn't go anywhere. That's fine in practice, but as I said earlier on at the beginning of the video, it doesn't highlight the potential mistakes that you can make, and also how you can do the procedure a little bit more accurately. So here we go, the technique that I'd recommend and that I'm going to use myself. First of all, remove the tyre. Now, I've made a separate video on how to remove the tyre without using any special kit. I've never done it before, actually. I've never removed the tyre myself, or in fact balanced the wheel myself, but I watched lots of videos on YouTube and kind of plagiarised other people's techniques and came up with a method that I think hopefully will work a little bit better. And certainly getting the tyre off was relatively easy without any special kit. So having removed the tyre, the next job is to clean the wheel, because there's no point in balancing it if the wheel's dirty and it's got bits of stone or bits of tar and other rubbish stuck to it. So clean the wheel up and remove the existing lead weights. Now, the best way to remove the existing lead weights, they're stuck on with double-sided tape, or what appear to be like a bitumastic glue in the case of this wheel. And you can get plastic chisels to remove them, but I found the easiest way was just use an ordinary hairdryer, put my fingernail under a weight, put a hairdryer on it, and whatever you do, don't use a heat gun, because they're incredibly hot. You do God knows what damage to the paintwork. So just an ordinary hairdryer. Put it up relatively close, put your fingernail underneath it, and put a constant prising pressure on the lead weights. And then as they warm up, the adhesive softens and they come off relatively easily. And then I just cleaned the goo off with petrol and isopropyl alcohol and just gave it a gentle rub, and that took all the adhesive off. So what we have now is a nice clean wheel with no lead weights. Now, the principle I'm going to use, you'll probably know that in theory at least, the lightest or heaviest point on a wheel is adjacent to and or opposite where the valve is. And manufacturers, in theory, although I haven't come across many tyres that are like this, in theory put a dot, a yellow dot or a red dot on the tyre wall to denote, again, the lightest or heaviest point on the tyre, so that when you mount the tyre, you mount it with the dot adjacent to or opposite, I forget which way around it is now, adjacent to or opposite the valve, so that any out of balance mass on the wheel is at least partially catered for by any out of balance mass on the tyre. That way, when you balance it finally, you need the minimum amount of lead, which obviously is to your advantage. I use the term lead advisedly, and I'll come on to that in a minute. Now, I'm going to use the same technique, except I'm going to do it slightly differently. So the wheel has been cleaned, the lead weight's removed, and I've actually balanced it. So the wheel as it stands now is balanced with some temporary weights attached to it. So the next phase is to put the tyre on, and when the tyre is on, I'll put it back on this unit and I'll let it rotate until the entire wheel, including the tyre, has settled. Now, because the wheel is balanced, when the tyre is on, whichever position it settles will tell me which is the heaviest and lightest point on the actual tyre itself. So having done that, if it's possible actually, you want the tyre, although the beads won't be seated, you want the tyre as symmetrically mounted onto the wheel as you possibly can. I don't know whether putting a small amount of pressure in there prior to the bead seating, whether that will enable it to push outwards against the drop centre here and allow the tyre to seat symmetrically. I'll cross that bridge when I come to it. But I suspect you'll be able to get the tyre seated symmetrically enough to get a rough idea of where this heaviest point on the tyre and the lightest point on the tyre is. Having found that, mark the tyre, and you want to mark the heaviest point on the tyre with a bit of red paint, red felt tip, whatever, it doesn't really matter, just mark the tyre. Take the whole thing off the stand and then manually rotate the tyre around. It should be easy to do because you'll have plenty of tyre wax on the wheel still and there's no pressure in the tyre. And again, the beads aren't seated, so rotate the tyre around until the heaviest part of the tyre corresponds with the lightest part of the wheel. And of course the lightest part of the wheel is where you've got your lead mounted on the rim. Once you've done that, it's probably not a bad idea to actually mark the tyre again with some red paint or yellow paint, whatever, that denotes where the valve is. Because what you want to make sure is that the whole thing will only stay in balance if the tyre doesn't at any stage rotate on the rim. And under extreme acceleration, which isn't going to affect this because it's a front wheel, or extreme braking, it's always possible, particularly if you get any amount of wax on the rims itself, that the tyre could rotate slightly. And in fact, if the tyre has rotated, you'll see, because you just have a quick look, and if your red bit of paint is no longer aligned with the valve and it's moved by 6 inches, you'll know that your wheel's potentially gone out of balance. So it's just belt and braces really. That's just a final check. So having positioned your wheel, your tyre, sorry, with the heaviest spot adjacent to the lightest spot of the actual wheel, then that's the time to dismount it from the cones and the bar, take it down to the local garage because I don't have a compressor, and pump it up and get the beads sat. And then, having done that, you need to obviously perform your final balance. Now, having mounted and seated the beads and inflated the tyre to the correct pressure, the next job is to perform the final balance. And so, first of all, the temporary weights that you put on this wheel when you're balancing the wheel on its own without the tyre, you need to remove them obviously. So mount the wheel on the unit and let it settle, and it will do so with the heaviest point at the bottom and the lightest point at the top. Now you need to accurately mark the exact top. There's no point, if you put weights on and you're about 1.5 inches, 2 inches, 3 inches either side of it because you're in a hurry or doing it in a little bit of a slapdash fashion, you're going to find problems balancing your wheel. So it does need to be absolutely at the 12 o'clock position. And again, I'll explain how I did that in a minute, or how I plan to do it in a minute. So stick an amount of weights temporarily, and the way I did that was to use some double-sided carpet tape and take the weights that I'm going to use, and rather than use the sticky backing on the weights, I just stuck them with their upper surface against the double-sided carpet tape. Obviously when the final weights are ready, I'll just take the backing paper off, turn them around and stick them on the wheel itself. Having done that, remove it, turn it round until the heaviest and the lightest point is at 90 degrees, release it and see what happens. Now it will go one way or the other, so you'll either need to add more weight or less weight. Now eventually you'll get to the point where you'll bring the wheel into the 3 and 9 o'clock position and you'll release it and it won't move. Now that doesn't actually really mean that your wheel is balanced. What it means is that any out of balance forces that are there are simply not sufficient to overcome the stiction, if you like, in the system. So in other words, the stiction in the system is greater than the out of balance forces, and you don't know actually by how much. Now the forces of stiction again are caused due to any eccentricity in the in the central rod itself, which might have a slight bend in it, a U-shaped dip. It might be caused by friction in the bearings. One or two possible causes, but either event, that's the case. The out of balance forces, they still exist. So what you would, or what I did certainly with the wheel, and what I'll do when I've got the tyre on, is I then add lead to one side, to this side here, until in half gram amounts, until there's just enough lead so that each time I release it, the wheel wants to rotate that way. So you know that it's just too heavy. And I make a note of how much weight that might be. Now let's say, for example, that I get an initial balance and I add lead in half gram amounts until eventually, by putting another 6 grams on here, it wants to rotate that way every single time. Then what I do is I take that 6 grams off and I go onto this side and I add in half gram amounts enough lead until eventually, releasing the wheel, it religiously wants to go that way. And if, for example, we say that on that side it needs 2 grams of weight in order for every time I release the wheel for it to go religiously that way, you assign a positive value to the weight on this side, so +6. You assign a negative value to the weight on this side, in other words -2. And you add them together to give you +4, and then you divide it by 2 to give you 2 grams. In other words, to achieve a perfect balance, I would have needed an extra 2 grams of weight on this side. So you've got a choice. You can either, if this is where all your weights are over here, you can either put an extra 2 grams on this side, which would be kind of a bit crazy, or just simply take 2 grams off the far side. Go through that again. Let's give another worked example. I've been adding weights at the top, bringing it to the 90 degrees and letting go of it, and I've got to the point where it doesn't want to move. So again, I could be out of balance, but those out of balance forces are less than the stiction forces. Now in this particular case, let's say for the sake of argument, it's not actually quite balanced. Every time I release it, it wants to move, let's say this way, away from me, very, very slightly. So it's not quite balanced, but it's near enough. But every time I release it, so I've got my lightest point here, my heaviest point here, and every time I release it, it wants to go that way. So I will add enough weight onto here so that every time I release it, it doesn't want to go, it just stops and it stays still. And again, I'm adding the weight in half gram amounts. Say for the sake of argument, it takes 2 grams. I then keep going in half gram amounts until every time I release it, instead of staying still, it wants to move this way. And say for the sake of argument, it takes 6 grams. Then the amount of weight extra that I need on this side is the difference between 2 and 6. In other words, 4 grams. You add them together, so 6 plus 6 added to plus 2 is 8, divided by 2 is 4. So I need an extra 4 grams on this side, or take 4 grams off this side. And that is the way to do it. And if you do that, you should be able to balance your wheel accurate to within plus or minus a gram. Now the way I produced the additional weights is I got some roofing lead, you can get it from a builder's merchant, and I cut it into a strip 5mm wide. In fact, you can see part of it here. 5mm wide and about 30 centimetres long. And then I weighed it accurately using some kitchen scales. And if you know that 30 centimetres of lead of a constant thickness weighs, in this particular case, I think it was 157 grams, it's just a simple matter to get out your calculator and work out how many centimetres is half a gram. And in this particular case, I seem to remember it was 4.18 millimetres. And so I just cut a section of lead, chamfered it down. Now you can't, using kitchen scales, weigh, even though they're electronic scales, they're only accurate to within a gram, and even then it flicks between 1 gram and 2 grams on the scale, so you can't accurately measure half a gram. But of course, if you know that a length 30 centimetres long weighs, a couple hundred grams or whatever, so it's very easy to do. So I ended up making a half gram section of lead and a 1 gram section, a 2 gram, a 3 gram, a 4 gram and a 5 gram. And so that is how I was adding weight incrementally. And again, I was sticking it onto the wheel temporarily using carpet tape. Now, by way of a demonstration on this wheel itself, you'll see that the lightest spot on the wheel, which is where I've got the majority of the lead weights. In actual fact, this is a section of weights that came off the original wheel, and you've got 5 grams, 10 grams, 5 grams, 10 grams. So that's one half of the weights that were already on the wheel, so you've got 30 grams there. And using that bracketing technique, I found I needed an extra 4 grams on this side here, and you can see where I've temporarily stuck that on. So this wheel now is actually balanced, and as I said before, I'll put the tyre on, I'll mount it, semi-inflate it if I possibly can without seating the beads, having rotated it into position, then subsequently rotate it into position so that the heaviest part of the tyre corresponds to this point here. And then that will mean that when I take all these weights off and rebalance the wheel, I'll need the minimum amount of lead weights possible to balance the final job. And hopefully we'll be able to do that with a relatively high degree of accuracy. Now, there are a couple of other points worth mentioning, and that is what type of weights to use. I was under the impression that you weren't allowed to use lead weights and that lead wheel balance weights were no longer commercially available, and I believe that is actually the case in the States. Certainly there has been a move away from lead weights for wheel balancing. If you go onto eBay or Amazon and look up wheel balance weights and try and buy them, they're nearly all steel weights. They're either zinc coated or powder coated. The problem with steel as a balancing weight is several. First of all, it rusts, so obviously it needs to be zinc coated or powder coated, not a big issue particularly. But obviously it's not as dense, and so you need physically more weight in terms of volume for the same level of balance. Now, the way they'll achieve that is the weights tend to be wider. Now, these weights are about 12 mils in width. And you can see on this wheel here, the actual flat area across the cord is probably about 2 centimetres. And then there's a hump in the middle which represents the drop centre of the wheel. Now, the problem with the steel weights is that, first of all, they tend to be wider, anything from 19 to about 22 mils in width. So a lot of motorcycle wheels, you won't have sufficient flat cord at the edge here on which to stick them. So they'll have a slight tendency to come off. And the other problem, of course, is that because the weights are, for any given amount of weight, so you've got a 10 gram weight, these 10 gram weights are probably, again, about 12 mils, something like that, 12 mils long. A steel 12 gram weight is a good 2 centimetres in length. Now, again, a lead weight, lead's nice and soft. So as you push it, particularly if you tap it lightly with a mallet, the weight itself will deform so that the weight will form a nice arc, and the adhesive tape will be in total contact with the wheel rim along its length, which means that the weights aren't going to come off. Steel weight, take a 2 centimetre steel weight, you're not going to tap that and get it to deform, and they're manufactured flat, but with obviously a section that will allow some bending in between successive weights. But it does mean that each weight will arch across the wheel rim from one end to the other, which means that, strictly speaking, when you're pushing it on to get contact with the adhesive tape, the maximum pressure that you'll bring to bear when you're sticking it on is at either end of the steel weight. And I have heard, again, I don't know from first-hand evidence because I've not done it myself, but I have heard that they are more difficult to get to stay on, and they've got a nasty habit of coming off. As it turns out, in the UK at least, you can still buy lead weights. They are still available. It does say for motorcycles, so whether they're legal for motorcycles and not for cars, I don't know. But be warned, steer clear, if you can, of steel weights. Use lead weights, and as I say, those are the advantages. When you come to use them, they're more pliant, so as you press them, the weight will deform, so it will form a nice arc. They're narrower, and you need physically less material, it's less weight itself. So you get a far more satisfactory job using lead weights. Now there are two final points that I would make about balancing the wheel. The first one is, let's say for example you're doing an initial balance and you've established the heaviest point and the lightest point of the wheel. And then you mark it carefully with a felt tip so you know exactly where the midpoint is, and you take, maybe in this case I've got 2 10s and 2 5s in a strip. And what you're going to do is you're going to mark the midpoint of that strip, and you're going to mark the midpoint so that it corresponds exactly with where you've got the felt tip for the uppermost point of the wheel, and put the weights on dead accurately. If when you bring it round to here and release it, it goes back up again, you know that you haven't got enough, and let's say for example you want to put another 5 grams on. What you don't want to do is put that additional 5 grams at one end, because that then means that the centre of mass of the weights that you stuck on it is actually shifted this way. And you'll find then that the wheel will no longer settle with the theoretically heaviest point directly at the bottom, and it will go off, it'll go out of kilter. So every time you want to add weight, you need to take off the original weight, work out how long the new section of weight is going to be, and mount it so that the middle of those weights is again dead centered around the lightest point of the wheel. And again, that's going to be quite important. Now the final point to make is how to establish exactly which is the 12 o'clock position of the wheel. So every time it settles, you need to mark that 12 o'clock position, and you need to do it accurately. Now the way I did it, and that's not set up to show you here now, but you'll just have to take my word for it. The way I did it was without the wheel. Let's just take this off. Without the wheel mounted, I stretched some fine fishing iron in between the centre points of these two bearings on either side and pulled them tight. So I had a midline effectively running between the two. And then I put this whole unit on the floor and attached a plumb bob on a piece of string hanging down in the middle here, and then moved this towards or away from it until it was just adjacent to the touching, if you like, the piece of cord that was running between here. Then once you put the wheel back on, which I'll do now, okay, so you have your piece of string hanging down here. What I did is I shortened it, took out some slack and tied a knot in it, so I shortened it so it was hanging up about here, and then I just simply moved it until it was just not quite touching the rim, so that each time this thing rotated, again, you knew exactly where the lightest point was and you could mark it with a felt tip. And that was how I did that. Now it is important, as I say, because if when you put your weights on, you put them, let's say 3 or 4 inches to one side, then what that will do, even if you get the amount of weight right, so let's say the wheel's 30 grams out of balance, and your heavy point is here at the bottom, and it's 30 grams too much, and in theory putting 30 grams in the 12 o'clock position balances your wheel absolutely accurately. If you put the 30 grams on but you get it a few inches in the wrong place, then what that will mean is that the new heaviest point of your wheel is here somewhere. So when you then release it and try and balance it, instead of one or t'other going to the top or the bottom, you'll find that they'll settle with a new position at the bottom. So again, it is fairly important to get the weights exactly top or bottom. Well, you're not going to put the weights at the bottom, but get the 12 and 6 o'clock positions of the wheel marked absolutely accurately. One other final point to make, and that is when you're balancing, when you initially balance, let's assume that the wheel's significantly out of balance, you will generally find that the heaviest point will go straight down to the bottom, and the lightest point straight up to the top. And then when you then, let's say for example you don't put any weights on just yet, and you rotate the wheel through 90 degrees so that the heaviest point is now here and the lightest point is over here, when you release it, at this point the out of balance forces, the moment from the out of balance forces is at a maximum, and as it rotates around, because this distance from the centre of rotation is gradually reducing, the out of balance forces are getting less and less and less until such time obviously you're at 12 o'clock and 6 o'clock and there's no out of balance forces. Now obviously as you add weight to it and the imbalance becomes less, what will happen is you will reach a situation where the wheel won't settle at 12 o'clock and 6 o'clock, because let's for example say that this wheel is badly out of balance and this here is my lightest point and that's my heaviest point. When I release it, it will go like that and it will oscillate a little bit, but it will settle with the lightest at the top, heaviest at the bottom. Now let's come here and say this wheel is almost balanced but not quite. The out of balance forces, the rotational forces, are at a maximum at the moment. As I release it, the wheel will start to go like that, but as it does, the turning moment becomes less and less and less and less and less, and it will reach a point where the turning moment equals the stiction in the system and it will stop. So you will actually find that you'll stop with your lightest point, not at 90 degrees, but at say, I don't know, 10, 15, 20 degrees off that point. So when you're balancing the wheel, it's not necessary to let the thing go around and settle. You really don't need to do that. All you need to do is establish initially your lightest and your heaviest point. Having done that, bring it to the 3 and 9 o'clock position each time and release it. And if the moment it starts to go that way, that's good enough. You need more weight. And so put more weight on it and do it again. Again, keep doing that until you release the wheel and it becomes static. When it's static, go through that procedure again, add weights in half grams amounts until you get to the point where it definitely wants to go that way. Make a note of how much additional weight you've needed, call it positive. Add weights on the other side in half grams amounts, having removed the additional weight from this side, until every time you release the wheel it wants to go that way, call it negative. And then what you do is you add the two amounts together. So if it required 6 grams on this side, you've removed it. It required 2 grams on that side, we'll call it -2, and you've removed it. Then plus 6 and -2 is 4, divided by 2 is 2. Then it means you need an extra 2 grams on this side. So it's fairly easy to do, and I'm confident if you use that procedure it will give you a far more accurate result. Witness the fact that when I balanced this wheel, for example, minus the tyre, my initial balance was just with these weights, but when I did the bracketing I did need an extra 4 grams on this side. Now obviously when I do the final balance I won't have a majority of weight on one side and a small amount on the other. If I find that with the weights on this side I need some more on this side, I'll just take these off and file them down until I've filed however much needs to come off. If it's 5 grams, I'll take a complete 5 gram section off. But if it was something like 1 gram or 2 grams, I'll just file an amount of metal off. That's it. I hope the video proves useful if you're daring enough to try this yourself. Thank you.